As now we are done with the two examples of the simple harmonic motion SHM, which is actually the simplest form of the oscillatory motion, and oscillatory motion is a type of periodic motion, right? Which means simple harmonic motion is actually periodic motion, oscillatory motion, and it is the simple form of the oscillatory motion, which means it is a straight line motion. That's why we consider three examples, right? So what were those three examples? The initial example was motion of a projection of a particle along the uniform circular path, which is the connection of the uniform circular motion and the simple harmonic motion. Second example we have discussed in very detail as well, motion under elastic restoring force, which is Hooke's law, or you can say mass spring system. In that, what we discussed about displacement, velocity, acceleration. We have proved that acceleration of the simple harmonic motion overall would be directly proportional to the negative of its displacement, since displacement is always taken away from the mean position and acceleration is always taken towards the mean position, right? Then we discussed about energy of the mass spring system, which includes kinetic energy, potential energy, and then total energy. We discussed frequency and time period of the mass spring system as well. In today's video, we are going to start discussing our third example, which is most important part of this syllabus, that is simple pendulum, right? Basically, we have two types of pendulums, right? The simple pendulum and the conical pendulum. But in this syllabus, we are not going to do conical pendulum. Conical pendulum is included in the circular motion, right? When we are going to discuss about circular and rotational motion, there we have simple pendulum, not simple, however, conical pendulum. But here in this chapter, in the simple harmonic motion or in the oscillation, we have one pendulum included, and that is simple pendulum. So what we are going to discuss, we are going to start our third example, which is the most important example, and that is simple pendulum. Simple pendulum. In today's video, we're gonna just discuss the basics of the simple pendulum, right? The terms which are included in the simple pendulum, and students get confused in it. They get perplexed since they don't know the terms which are used in the simple pendulum. So what we are going to do today, we are going to learn the simple terms which are used in the simple pendulum, right? So for that, I need to make simple pendulum here first. This is a string. We're going to discuss each and every term in very detail, right? This is a mess hanged with this spring. I gave force, and this is here now. Again, this will go here, right? So now let's start discussing this. Initially, this string is what we call the inextensible spring. This is also known as weightless spring. Wait, let me write this first here. What is this? It is consist of, the simple pendulum is consist of weightless and inextensible spring. Inextensible spring. Now what is mean by this inextensible spring? Inextensible spring means it is not stretched, right? What it is not stretched at all. And if the spring is not stretched, this is what we call the inextensible spring. Not stretched, right? Which is termed as inextensible spring. So wherever now you hear the term inextensible spring in the simple pendulum, you must get that the spring is not spring, we cannot say spring, it is string, right? So string is stretched, it is not stretched, so this is inextensible spring, which means it is attached to a fixed support to which a body of mass m is suspended. Okay, so what we can say, not stretched, or you can say it is attached to a fixed support to which a body of mass m is suspended. Okay, so this string is what we have called weightless or inextensible spring. Okay, second thing, this mass, this suspended m mass is what we call the bob in the simple pendulum. This is bob in the simple pendulum. So mass m which is suspended to a fixed support to a weightless and inextensible string is what we call bob, right? Now see, this bob will experience three basic forces. Initially, this string will have tension with it. Tension is also a force, right? And tension is along the string, right? Secondly, it will have its weight which will act downward, mg. We're gonna break this weight into its two components. Initially, it's this component which is what we call the w cos theta, since this is making angle with it. Okay, and its another component would be here, which is w sin theta. So what three forces are acting on a bob? The three forces which are acting on the bob are the tension in the string, okay, parallel wx component of weight, and perpendicular wy component of the weight. So let me mention this here. Three forces are acting on the bob. The first one is, I'll change the color of it, okay, tension in the string. The concept of tension we're gonna study in very detail in the circular motion chapter, right? There we have a detailed topic in the Punjab textbook. Second, we have force here, which is the parallel component of the weight, and you can see which one is the parallel component of the weight. It is w cos theta. Parallel, which is wx component of weight. Thirdly, we have perpendicular. Which is wy component of the weight. So what we have discussed in today's video is, we have discussed basic terms which are used in the simple pendulum. We have seen forces which are acting on the bob. There are three basic forces, right? which includes tension in the string, parallel Wx component of the weight, which is W cos theta, and perpendicular Wy component of the weight, which is W sin theta. And we discuss basic terms, which includes weightless or inextensible string, and bob, which is M mass suspended to the string. Okay, so in the next video we're gonna study more about it when we apply force in it, and the body covers some displacement, what happens, we're gonna study.